Hello everybody, welcome back to my YouTube channel. So today we're going to take a look at a new paper, right? And it got me thinking, right? There's a lot of different ways to use large language models to help to boost graph neural network model prediction accuracy, right? But but typically there are like two different kind of approaches. One is to use the LLMs to directly predict the property of a graph, right? So you can use some kind of a prompt engineering and fine tune it to make the prediction. But usually the accuracy is kind of bad with LLMs, right? On the other hand, there's this very common approach, right, that I think everyone's using right now in the community, and that is to use the LLMs, right? Have the LLM generate some kind of a node label, right, to generate the node features, and then we take the node features into the GNN in order to boost the GNN's accuracy. But in today's video, I just discovered a paper, right, that somehow does this approach differently, right? What it does, from what I can tell, is that you ask the graph neural network to consult the LLM when it's uncertain about some of the information of the graph, right? In that case, if it's unsure about something, then the LLM can provide new insights for the GNN, and this kind of system will help to improve its accuracy. So, so let's get right into it, shall we? But first of all, right, let's get into the results here. So, so let's take a look at the results. And the more interesting result that I want to point to is actually this one right here. So so let's see. Aha, right here, right. So if we directly use the LLMs as predictors, we often get right a reasonable accuracy about 70 plus percent, right? But if we use the LLMs as enhancers, right? So basically LLMs and then feeding into the GNN, right? In this case, they're using Llama 2 chat, and they found out that if you do that, you will often get accuracy that's like around 86%, and for PubMed, it's around 90 plus, and so on. And it's significantly higher than directly using the LLMs for those tasks. But as soon as we get to this part right here, right, with their new consultant approach, the accuracy goes up higher for certain graph neural networks. For example, for graph convolution network, for Cora, there is a significant boost of accuracy here, right? But for like but for MLP, it decreased somehow. But to be fair, MLP is not a graph neural network. Sorry about that. All right, and let's take a look for PubMed. So for PubMed, the MLP accuracy actually increases, right? But then again, right, there is one thing that I have to point out here, though, that I just realized right now, is that they are using Vicuna, right? And Vicuna can be thought of as like I think Vicuna is a better model than Llama 2. I'm not so sure why they can't keep the comparison using the same LLMs, right? Because the better the LLM is, right, it's just going to skew the results. So there's a problem with, so the results use different LLMs. So this parameter is not kept constant. I don't know why, but let's have a read. For archive 23, well, the accuracy is not that much better for MLP and GCN, but for graph sage, it's better by a bit. Well, okay, guys, I feel like you guys can click away from this video now because I feel like this paper is not that great. Judging from this, right? And also another thing that I have to point out is that they don't have the GNN for comparisons, right? So where's the comparison, right? Where's the comparison? You should just like use the GNN and then report the accuracy here, because all we know, right, is that, oh yeah, if you use the LMs on itself and then it starts off with like 70+% accuracy, but as soon as you use the LM on the GNN, it gets better. But it could be the case that the GNN is actually doing much better without the LM in the first place, right? So I don't see like we need more comparisons here. We need more controls in the study. So, or maybe I missed that, but they should have included that in the table, right? So let's see. Okay, right. So, and I'm gonna say this, that if the result isn't that good, right, there's no point going through the entire paper, right? Because that's just a waste of bloody time. So let's see right here. Okay, blah blah blah. Okay, right. And they show that with this new consulting approach, right, you essentially get better accuracy, right? So the accuracy improves as you use better models. Obviously, using GPT 3.5 from OpenAI is gonna give you 80, 80 to almost 90% accuracy compared to like other open source models. But you know, you know, they should have just used Llama 2 just to be consistent with this comparisons that they're trying to make. So that's kind of disappointing. Um, Look, okay, that's the ablation studies. We're not gonna get into that right now, but okay, look, all right. Let's see what else more. I have no faith in this paper already. Okay. Oh man, this is okay. Right. All right. How about this? Right. Guys, we go through the abstract together first. I got to admit that the abstract is kind of like useless in some way. All right. So okay, let's go through it regardless. Okay. GNNs. We need better ways to improve GNNs right here. LLMs as consultants. Yeah, consulting the GNN. And they have this like really bad abbreviation, a really bad name, right? LLM consultant GNN training. Why do you pick the the letters that are like in between the words? Like don't do that, right? It should be LCGT, right? It makes much more sense than login. What do you mean by login in this case? Anyway, yeah, I don't like the name. First, we attentively craft concise prompts, right? So the craft prompts for spotted notes. Okay, I assume the GNN spots some notes. In this case, it isn't explained. Okay, carrying information, whatever it may be, and use it as an input to the LMs. Then they have to refine the GNN by using a coping mechanism that utilizes responses from LLMs. Basically, it just gets the responses from the LLMs. Don't know what they meant by coping, depending on their correctness. So they evaluate it on node classification, homophilic and heterophilic graphs. Well, Homophilic and heterophilic graphs, those are just two different types of graphs where I think homophilic is about like the nodes having the same attributes or something. I will have to see. Right. Homophilic graphs. Okay, let me see. Yeah, so I think the homophilic graphs is like the same weighting for each nodes, I think. So I used to remember the definition, but anyway, I don't think that's important right now. And the code is available, right? But the results are not that great if you ask me. And I don't really mention about like, okay, usually the usually, right, if the accuracy improvement isn't that great, right, in comparisons to the standard approach that we already have, is to take the LM and generating some kind of an output directly into the GNN. That's a really common approach and it works quite well. But in this case right here, they are saying that, oh yeah, with this new consulting LM consulting approach is much better. But in that case, right, the results are not really showing that, right? Instead, it is mostly comparable with the standard approach. And it also doesn't mention anywhere in the abstract about like, oh yeah, are there like any new benefits to this approach? Yeah, so usually if the accuracy improvement isn't there, right? Usually what other papers would do is to like, oh yeah, but our approach is more computationally efficient, right? In some way, but it's just not here. It's just not here. Um, yeah, that kind of sucks. Um, I'm not saying this paper sucks, right? I'm just saying that there are better papers out there. Okay. Anyway, I would just go straight into some of their methods, right? So, okay, we can skip some parts here, right? Okay. Since okay, so their login approach, hate that name. Okay, so they do one thing, right? So let's take a look at the figure here. So, okay, I'm just gonna do some guesswork because I'm not gonna read the entire paper now, given that the results are kind of bad. So, okay, human annotation, GNN prediction, LM prediction. Okay, got it. Right. So a bunch of GNNs and have them predict labels, and somehow you have some kind of a neighborhood of the uncertain node, and then you create a prompt, right, telling the LLM, okay, try to classify what kind of node here, and it comes up with a response. Either the LM is right or the LM is right, and you do some kind of like H printing or feature update, and basically it goes through the cycle. Okay, so that's the highlight, the figure there. Obviously, my interpretation will not be correct because I haven't read the entire thing. But what's the point of reading this really if the if the results are that not significant, right? I mean, for something that doesn't work. Oh, okay, sorry. Yeah, yeah. If the method doesn't even work, why do I have to spend time reading this? I could be reading something else, really. So let's see. Okay. Formally, the target is to learn GNN parameters to predict the unlabeled nodes with the guidance of LLMs. So basically, right, if the GNN is uncertain about something, then okay, given a graph subgraph where the zero node is the target node along with the textual context, please classify the node. Okay, right. Okay, and there's some Bayesian stuff here. Is to construct this to utilize the capacity, blah blah blah. Okay. All right. Look, guys, I'm not gonna go through this anymore. Yeah. Yeah. yeah, this paper, the results are not great. Yeah, I won't waste my time on this paper anymore. Unfortunately, you know. So yeah, yeah. If you like this video, make sure to like and subscribe. Yeah, but that's it from me. Catch you in the next one. Bye.